All right, here we go. So we're going to look at the buffers assignment. And here we're going to work with Nodejs' buffer class. And that's for, obviously, buffering data, chunks of raw data. It's important for working with chunks of raw data. And there's documentation on that, of course, which is good to read. Here it is talking about the buffer class. And maybe we'll come back to this when we need to. Well, it goes deep in there. What's inside of, is it like the I/O module? Well, it's a huge, huge module. It's the all, it says all. Global object. Oh, I see, it's a global object. Buffer. So it's some sort of foundational object which is used in many places, and it's not part of a, what do you call it, a module. It's a global object. All right, let's go back to here. So we're going to end up creating two files, main and root. And this will be a simple server. We're just going to return a string and return that to the connecting browser. So let's go ahead and look at this code. I'm going to copy it. We're going to examine this. And this goes into main. I'm going to create a directory called buff, cd into buff. Nothing in there, obviously, so main.js. There's the code. So we've got these modules, HTTP, domain, and this is a module we're going to write called root. And that's the name of it is because we're going to service requests for the root resource, just slash by itself. So the URL will be, the host name of the server with just a slash. That's called the root resource. And then we looked at this last time. This is a function that we call when we have an error. We just pass in the result, the response rather, the response object, and it returns a HTTP header with the code 500 in it. That's called the response header. And then we have a not found response for connecting clients that ask for things that don't match with what we're serving. Then we tell them that the resource is not found. Here's the request handler. The request handler takes a request object and a response object. Where each time a browser connects to the server and sends a request, Node creates a request object and a response object, two different objects, and passes it to our request handler. That's why we have this. And this is typical. You see this in other language environments, like Java, for instance. This is how Java servlets work. And we just do a logging statement there. And if the request is for slash, then that's a root request. And then we'll delegate the processing of that request to our root module. So remember at the top here we required root there. That's our module for handling requests to the root resource. Any other request we're going to say it's not found. So we're only going to send back one thing. And of course we have our server down here. We create an instance of this HTTP server that's provided to us through Node, and we register a request handler. So the on is we're registering an event handler, and the particular event we want to respond to is the request event. When a request message comes in, that means when a HTTP request message comes from the browser, then we want this function here to run. And so we don't pass in our handle request function directly. because we looked at this last time, that's a problem. If we generate an error, it's going to bring down the server. So we wrap the request in this sort of domain object. So first thing we do is we create a domain object, and then we configure things like this. And finally, on the domain object we call run, we pass in a function gets invoked by run, and that function simply calls our request handler, passing the request and response object that got passed into us from the HTTP server. So it's a bit messy, it's hard to understand this, so you've got to spend some time on that. But this protects the server from shutting down if there's an occasional exception that's thrown in our request handling code. That's the purpose of that. We examined that last time. I don't have a recording of that session, but we did talk about it last time. So we're going to listen to port 5000. So now what we need to do is implement this root module. Here it is. So when this is our module, we import this module, HTTP, and we create a buffer here by calling this buffer constructor, new buffer. That's the buffer constructor. And we pass in the data in the first argument, which is going to be a string, and then we tell it how we want the character data to be encoded. We want it to be in UTF-8 encoding, and that's standard for web traffic. So web pages should be in UTF-8, for instance. Text documents that are transmitted over the web and handled and rendered by the browser, like CSS files, JavaScript files, HTML files, they should all be in UTF-8. You could change that, of course. You can use different encodings, but this is the standard that most people are following. So we're going to make sure that that's in UTF-8 encoding. And then we just store a reference to that buffer object here with the variable named body. And here's our handle method. So this is what's exported. It's a main, yeah. See here, no, I'm sorry. So right here, you see on our root module, see here root, we do root require here. So we can access the exported properties and functions in that module. So to access this handle function, it has to be exported. That's why we set handle as a property of this predefined exports object. That's what exposes our functions and variables to code that's outside our module. It's just a basic design for the module. This variable here, body, that is not visible outside our module. It has module scope. It doesn't have, in a browser, this would have global scope, but in Node, it does not go to global scope. It's kept in module scope when we make a declaration like that. As well as this is also in module scope, this particular module. So we set this this handle attribute on that exports object, and we do it with this anonymous function. So we set it to this function. And of course, there's other ways of doing that, just to show you the alternative. We could have done it like this. We could have defined a function called handle. And now this function has module scope. And then we just set we create an attribute on the exports object and just set it to the function reference. So these lines right here are essentially give us the same thing as this. These are fewer lines there. If we needed to to use this function name somewhere else other than just to set this down here, then this is a good, you would have to do it like this. But because this handle function is not called by anything other than outside code, we can define it here as an anonymous function and then set that into this handle attribute. So you might want to do it like this if this is easier for you to understand. It's all about readability. But you see this a lot in Node programs. So what happens when this thing runs? When we get a request object and a response object, well, what we're going to do is we're going to write this, write the headers, and we're going to say the content type is text/plain. So it's just plain text. If we were sending back a web page, it would be text/HTML. And we're telling the browser that the character set is UTF-8. And that's synchronized with our character encoding setting here when we created that buffer object. So we tell the browser that it's this content type, that it's a text plain, and we write that. And also 200. This means success. And then we send the data. So notice these are calls on this response object. First we write the head. So when the response object goes out, you've got these headers, these lines of information. This is called the response header. It's the first header that goes out. There's other headers, like Node is going to throw in some other headers, and we're going to examine those. And after the headers, there's a blank line. And Node's going to insert that in for us. When we run this, and the blank line gets inserted. So you've got the headers, which are character line feed terminated character strings, one for each header. Then you have a blank line, and then you have the data. If you're sending image data, audio data, HTML data, whatever, and we're sending just plain text character data. That comes after the header section. So we do that with this. So we call n. So what n does is it sends out the data that's in here in this buffer, and then it terminates the message. It says that's it. It tells the browser that that's all the data that it's going to get. You can send out chunks. You would do, I think it's response.send or response.write. I don't remember what it is. I have to look it up. So it's optional to send this. We could have also done this. I think this is right. We could have a sequence of writes, so we just write one thing, and then we tell Node to flush everything out, end off the message. But I don't think that's as efficient as the way we did it before, so I'm going to go back to that other one. And we're going to make this even more efficient, actually. In a second, I'll show you how that works. All right, so let's look at that thing run. Oh, sorry, in the wrong folder. So we're running the server. And now let's go ahead and send in a request. So it's a localhost 5000. I'm a codfish. That's what it says. See, look, it handled the request for this. We sent back not found. Now let's send in that request again. I'm going to pop open this web developer view, and let's look at what's going over the network. All right, let's send the request in. Now watch what happens. And so we send in a request for this resource, localhost. That's the root. It's localhost / There's nothing after it. So that's what we're requesting. And we sent a get request. And we got a 200 response. Remember, we had that 200 here. That's where that number comes from. And now if we look at the details here, let me see, where do I find those details? I think it's in here, just there it is. So I clicked on there. This is Chrome. You know, Firefox has got a really nice way to view this as well. But I learned how to do it in Chrome. These are summaries, but I like looking at the source personally. This is what's actually sent. So this request headers, this is what the browser sent to our server. So when we got that request object, when we got this request object here in our handler, it contains all of the data that was from here, that was sent to us from the browser. Here the browser is telling us what it sent to our server. And our server, in other words, we could dig in and access the cache control header, and it would show that the browser told us it set that to no cache. So we could retrieve that little piece of data there from that request object. But the only thing we really looked at on the request object was this first line. By the way, the first line is a special header line. It's called the request header. All the other lines are, actually I don't remember the name of it, but these are request headers, and the first line is the main request header. And there's some precise terminology I used to know. And so it's the type of HTTP request. Usually it's GET or POST, almost always those two. They have others like delete and head and so on, which are not used so much. And then that's the first element in the request header. And the second is the resource name. And I said we had the root resource. You remember when we were looking for that right here? We checked request.url. Node places that field, that second field in the request header, the first request header, it places that field in this attribute of the request object. That's why we get that here. If this could have been get/index.html, then that would have been in/index.html. See that? So this is called, that's like the resource, the path name to the resource. Because it could have folders in there. It could be private /index.html, whatever. So you could have it's like a path name. It looks a little bit like a file system path name, but it's a path to your resource. And then the third component of the request message is the protocol version number. And this is the one that's widely used now. The first protocol version that came out was 0.9. That was quickly replaced by 1.0. And 1.0 had some major issues with it. It didn't have this thing called cookies. So you couldn't establish login sessions very easily. And that was added to version 1.1. And a lot of caching, half of the improvements, half of the spec for 1.1 is all about caching. Lots of ways to manage caching. So anyway, this is the current version of HTTP. It's the one you'll almost always see. Andrew tells us that they're working on a newer version. We'll see what happens with that, but it's going to come out. It's been a long time coming, and it's not really needed. Essentially, this is sufficient. After they got to 1.1, it was good. Here's the host name with the port number. We could pull that out, of this request object as well. Once again, all that information is in that request object. Now here, look at this. This is the response. This is what we sent the browser. So now the browser is showing us what we sent it. And the response header, the first response header, always starts with the protocol that the server is using. So the server here is echoing back that it's using the same protocol, same version. And then the second argument, the second component of this first response line is the response code. 200 means everything is great. That's the one you want to see. And then this could be anything. It's just a human readable thing. I don't know, did I put OK in there? I didn't say, I just said 200. So Node put in okay, but we could have overwritten that and put in some other message if we wanted. Probably, I think. And then like the content type is text/plain char set equals UTF-8. Do you see that? That's it right there. That's the content header that we passed into it. It's coming back. Now look at the other information. The date, the connection keep alive, the transfer encoding chunk. Node added those. We didn't do that. And what does this mean? Connection keep alive. That means they're talking about the underlying TCP connection. So you make this communication connection between the server, the browser and the server. It starts from the browser side. It does this thing called a TCP handshake, establishes this two-way communication channel, and they start sending data back and forth to each other. And what this keep alive is, the server is telling the browser, hey, keep the TCP connection open because I may send you something else. Like you may turn around and immediately request an image or a CSS file. Normally you would do that. So we could turn this off because for our application, this creates waste because there's nothing else. We send a text message and that's it. So we should turn this off. That would save bandwidth. That would save compute resources. If it's a normal web page, normally the default should be to keep alive because normally a web page, you retrieve a web page that's got references to images, CSS files, and so on. You got to immediately reuse that TCP connection to retrieve all that other stuff. So you cut out that TCP handshake operation, which is some expense there that you can cut out. And if you're handling a lot of clients, if you cut out waste and pay attention at this level, you could save a lot of money. I mean, how much do you pay for a server? It's like you got 10 servers or 20 servers. If you study the details and cut out the waste, you can cut back from 20 servers to 10 servers. I mean, why not do that? How much are you going to save? Like $3,000 a month or whatever it is, plus all the bandwidth. So for big operations, like Twitter and Facebook, they're paying very careful attention to this. They are shaving bytes off here and there whenever they can because they save a lot of money that way. Now, what about the transfer encoding? This is how when the response comes from the server, it's going to send data. So how do you send the data? You just send the string. See, and when we sent the data, we didn't tell it how much data we were sending. We said, we're going to keep sending until we tell you we're not sending anymore. So this says we're going to send the data in chunks. And each chunk is got, like, I think it's 4 bytes at the beginning of the chunk, which is the number of bytes in the chunk. And you send these length prefix chunks one after another, sequence of them in that TCP connection, until you get a chunk with 0 length. That means that's the end. So there's no other chunks. So it's the browser is responsible to, concatenate all those chunks together and look for the 0 and say, okay, that's done. Well, that's inefficiency because we know in advance how much data we're sending. So what we're going to do is we're going to add another field here. We're going to send another header that's called content length. And the content length, we're going to tell it how much. Am I doing that right? I am not doing that right. I can't think and talk at the same time there, apparently. The content length is going to be the number of bytes we're sending. So it's body dot, is it length? Is that right? That's how many bytes we're sending. So it's like, now watch what happens when we do that. I'm going to restart the server. And now we're going to request this thing again. Look at that. It's not the content, there's not a chunked encoding anymore. Now we got the content length set to 14 bytes. Now it saves a little time. we're still keeping the connection alive. We can turn that off. I'm not going to get into that now, but we could do that. But I wanted to focus on it. The assignment is to actually add that header to examine this, see how it affects that. So it's the same thing. We get the same result there. I think that's all there is in the assignment. Is that right?
That's true.
Yeah. So it's pretty straightforward. Oh, this is a very nice article. Trevor Norris wrote this article about high performance. Oh no, it's not an article. It's a YouTube video.
Yeah,
And this guy's great. He's involved in writing code for Node. He's working on the Node source code, and he started out as a JavaScript programmer, and he's very good to listen to. And he talks about setting the content length header. He says it significantly boosts performance in Node.js, as well as other servers too. So I think that's it for